So you will notice that I've written here 3 pieces of data. There's actually 5 pieces of data we need to create a box and whisker plot. We need a median, which is actually the center number. We need the first quartile, third quartile. We need the lowest or smallest number. And we need the highest or largest number. Those 5 things will give us the data set we need to create a box and whisker plot. Well, if we want to find the center number and all of these different things, we actually need to put our numbers in order. So the first item of business to creating a box and whisker plot is actually to put the numbers in order. So let's do that. Looks like the smallest number is 53. There we go. The numbers are now in order. The next thing we need to do is basically just find the middle one. Well, the easiest way to do that is just to mark off each end one at a time. If your data set's huge, this gets a little tedious. This is the biggest data set I'll probably work with students. Not much bigger than this. Looks like our middle number is 79. So the median is 79. Easy enough. We've taken care of the center. Now we're looking for the first quartile. Now a key to the definition of quartile here, like I said earlier, is the word quart. We're looking for the first quartile, meaning we're going to divide our data set into 4 different quadrants. Make sense? So if you look at the first fourth, we're going to need to find the middle of the top half. Well, let's find the middle of the top half. We've used this, so we've got this set of numbers left, and the middle of that set of numbers, if we do the same thing we did before, we can call it the median of the top half, is 69. So quartile 1 is 69. Found the first quartile. The third quartile is much the same. It's the median of the bottom half. So we look at this bottom set of numbers and we look for the median. Look at that. That middle number is 87. So quartile, if I could spell, 3 is 87. Now can you see we've effectively divided this set of numbers into four pieces evenly. Okay? And we'll look at the box plot to see if the evenness of the box plot matches the evenness of what we have here. Now let's look at, since we've found this one, now let's look at the lowest number. Oh, that's easy. And the highest number. There. And we found the 5 pieces of data we need in order to create our box plot. Let's show you how to use them. Now we're going to create a number line. Number lines are used to make sure everything we do is uniform. I like to make our number lines straight and divide them evenly so that our box plot will truly represent what's going on. Yeah. Looks like our lowest number is 53, so we don't really need a 0. We can start with 53. Well, let's see, our highest is 94. So if we go 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, that'll work quite well. So let's go 50. just like that. Now we've got a number line that's going to allow us to lay out this box plot uniformly. And in a later video I'll show you how to compare box plots, so it makes this number line even more essential, so that we're comparing this apples to apples per se, so we're comparing the same numbers to the same numbers. Let's lay out this box plot. Okay, the lowest number is 53, so let's go just above here and mark where 53 is on our number line. The first quartile is 69. Let's just mark 69. You can use a dot or a little line like this, either way. The median, or we could call this the second quartile, first, second, third quartile. All right. The median is 79. The third quartile is 87. And the fourth quartile, 94. We have these 5 lines here. The key to creating this box and whisker plot is to remember it's a box and whisker plot. And so the middle 3 right here are going to create the box. And then the last 2 are going to create the whiskers. Hence the name box and whisker plot. All right, and you might mark them: 53, 94, 69, 79, and 87. All right, now remember, this was the first quartile, this was the third quartile, this was the median, this was the low, and this was the high. So why is a box plot important? Well, what we can say is, in each of these sections right here, I'm going to mark in this other color, looks like it's purple. Each of these sections represents 1/4 of the data. That's 25% of the data. Think in terms of $1. Each of them is a quarter. Remember that we split this data set into 4 equal parts. Remember that? These 4 equal parts right here. Physically, we split it into 4 equal parts. And the question is, if we look at this, do they look like they're equal? The answer is no, they're not equal. Even though we put 25% of the data in each of these sections, some of them are smaller than others. What that means is this thing is skewed. All right? It's skewed left because it has a tail. In fact, if we were to graph this thing, it would look something like this, where it would come up on this side. But you'll notice the tail is longer on the left side than it is on the right side. That means it's skewed left. I just wanted to give you an example of one, how to create a box plot, and what it is you can see once you lay that out. In other words, whether or not something is skewed and which direction it's skewed.